Welcome back, my dear future stars of Max and my viewers and my subscribers. Now, I would like to thank my viewers and subscribers for watching my videos. Please watch this video without skipping any part. Let's continue our exercise 2.2 third sum. So, the third sum is A equal to 2, 4, 6, 8, 10 and B equal to 3, 6, 9, 12, 15. Find A minus B and B minus A. So, in sets the subtraction will be different. So, you all see students how to do the subtraction in sets. First, we have to find A minus B. So, I wrote A minus B here. Now, in place of A, we will write the set A. Okay, all the elements which are in set A, we will write here. 2, 4, 6, 8, 10 minus B. So, the elements which are in B, that set we will write here. 3, 6, 9, 12, 15. So, now how to do the subtraction? First, we have to see the elements which are common in both the sets. So, we'll check that. Here we have 2. In this set, we don't have 2. Next element is 4. Here we don't have 4. Now, the next element is 6. In this also, we have 6. So, what we'll do, we'll cancel the same element here. Okay, 6 is here and here also. We'll cancel that. Now, the next element is 8. We don't have 8 in the B set. Then 10. We don't have 10 in B. So, only one element is common. So, we have cancelled that. Okay. Now, the answer, we should write the elements which are remained in first set itself. That's all. Okay. We should not see these elements. Only the elements which are remained in first set that we have to write in the answer. Okay. I'll show the subtraction using Venn diagram also. Okay. Now the fourth question is, if A and B are two sets such that A subset of B, then what is A union B? Explain by giving an example. So here we have to find A union B, but the sets A and B is not given. So we have to write few examples and then find what will be A union B. To do this, first there is a condition given. What is the condition? A subset of B. That means, what is the meaning of subset? Do you know, students? This sign is for subset. Okay. That means the set A and B, how they are related? The set B is big and A is small or equal to B. Okay. How the set A, it comes from B. That is the elements which are in B. In these, if few elements are there which are taken out from it, then we get a new set that is called as A. So, many subsets can be formed. It depends upon the elements which are there in B. So, if B contains 3 elements, suppose, okay, then how many subsets do you get? Do you know, students? We will get 2 power n subsets, where n is number of elements, that is 2 power 3 equal to 2 into 2 into 2. That is 8 subsets we can get. If a set contains 3 elements, we will get 8 subsets. Okay, among these 8, any one can be A. Okay, so now let me show you that. First, we will assume the set B. Okay, so B equal to, if I take 1, 2, 3, then what will be A? A is subset, it is given. So, subset means any one element or any 2 elements or all the 3 elements can be there in A. But I am taking only 2 elements here, 1, 2. In other words, we can say that A is the daughter or son of B. That is, from B we are getting A. Okay. Now, we will find A union B. So, A means, first we will write the set A union B. B is 1, 2, 3. So, union means what we will do? We will unite all the elements in one set. all together we'll write. Okay, 1, 2. Here 1 we have, but we already wrote 1, so no need of repeating that. 2 also we wrote. The remaining element is 3. So what we are getting? We are getting the further set, that is B itself. Okay, that is the set which is a subset. A is subset of B. So B is big and A is small. A is the daughter of it. So the answer for union we will get what? The B set. If we do intersection, what we will get? Do you know, students? Let's see that also. A intersection B. 1, 2 intersection 1, 2, 3. So the answer will be the elements which are common in both the sets. Here we have 1, here we have 1. So 1. Here we have 2, here also we have 2. So 2. No more elements in A. So we'll close this set. So what answer we are getting? The daughter or the son set. Okay. That is the set which is small, which is extracted from it. Okay. So when we do intersection, we are getting the subset, and we are when we are finding union, we are getting the set itself. Okay, from which we are finding the subset. Okay, is it clear, students? Now we will do the next sum. The fifth sum is, let A equal to x such that x is a natural number, B equal to x such that x is an even natural number, C equal to x such that x is an odd natural number, and D equal to x such that x is a prime number. So we have to find few things, that is A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. So first to find all these, what we have to do? We have to convert the set builder form to the roster form. That is, it is given in English. Now we'll write the sets in max. Okay. So what is A? A equal to x such that x is a natural number. So what are natural numbers? Numbers that start from 1. Okay. 1, 2, 3, 4, 5 and so on. Okay. So the next set is B equal to x such that x is an even natural numbers. In these natural numbers, the numbers which are even, that we have to write. Okay, what is even? Do you know, students? The numbers which are divisible by 2. Okay, so numbers that are divisible by 2 are known as even numbers. So that multiples of 2 will write. 2, 4, 6, 8 and so on. Now the next set is C equal to x such that x is an odd natural number. That is what? Whenever we divide a number with 2, if the remainder is 1, then what we say? Those numbers are called as odd numbers. Remainder is 1. Then those numbers will be called as odd. Okay, this divisible by 2 means they are even. If they leave remainder 0, we get even number. If they leave remainder 1, we get odd numbers. So what are our odd numbers? 1, 3, 5, 7, so on. Here, what is D? X says that x is a prime number. That is, for prime numbers, they have only 2 factors, that is 1 and itself. The numbers which occurs only in its table or in one table. That is, it cannot be divisible by any other number. Those numbers are called as prime numbers. So you should remember one point here while writing prime numbers. 1 is neither a prime number nor a composite number. Okay, students, these all things we studied in our very first video. If you don't know, then you can watch our first video. The link is in the description. Okay, so the prime numbers will start from 2, 2, 3, 5, 7, so on. Okay, Now we have to find these all things. A intersection B. So the set A we will write here first. 1, 2, 3, 4, 5, so on. Intersection B. So B is 2, 4, 6, 8, so on. So what will be the answer? The common elements. Intersection means what? Common. Okay. 1 we don't have here, so we can't write 1. Now we have 2 here. Here also we have 2, so we'll write down 2. Next element is 3. We don't have 3 here. 4 we have on both the sides, so 4. 5 is not there. Then we will have here 6. So 6 is present both the sides, so we can write 6, and so on. Okay. Similarly, we can do A intersection C. So what is A? All natural numbers. 1, 2, 3, 4, 5, 6, and so on. Intersection C. So the set C is here. 1, 3, 5, 7, so on. So it is equal to 1 we have here and here. So we will write 1. 2 is not present in the second set. 3 is on both the sides, so we will write 3. 4 we don't have here. 5 we have here. So on. Okay. Understood, students? So we will do the next bit, A intersection D. So A intersection D. So A is 1, 2, 3, 4, 5, 6, so on. Intersection D. What is D? 2, 3, 5, 7, and so on. So what are the elements which are common? 1 we have here, we don't have 1 here. The next element is 2. We have 2 on both the sides. 3, here also we have, here also we have. So we'll write 3. 4 we don't have in the second set, so we'll not write 4. Now here we have 5, here also 5. So we'll write 5. 6 we have here, but here we don't have. So on. Okay. Now the next bit is B intersection C. So what is B? 2, 4, 6, 8, so on. Intersection C. C is 1, 3, 5, 7, so on. So again we'll check the common elements. Here we have 2, here we don't have 2. Here we have 4, here we don't have 4. Here we have 6, we don't have 6 here. 8, we don't have 8 here. So no element is common. Okay. So what are the elements in the answer? We don't get anything. That is, we will close the bracket here. This means it is a null set. So it is represented by this symbol. Okay. It is called as pi. Okay. Now the next is B intersection D. So the B set is same. 2, 4, 6, 8, so on. Intersection D. What is D? 2, 3, 5, 7, so on. So what is the elements that are common? Here we have 2, here also we have 2. So we'll write 2. Next we have 4 here, we don't have 4 here. 6, we don't have 6. 8, no. Only one element, that is 2, is there, common in both the sets. So no other element. So we'll close this. So in this set we got only one element. Here we didn't get any element. Here we are getting many elements. That is, we are writing so on. That means this set is infinite set. Okay, you'll know these finite, infinite sets later in the other exercise. Okay. Now the last bit in this sum is C intersection D. So what is C? C is 1, 3, 5, 7, so on. Intersection D. D is 2, 3, 5, 7, and so on. So what is the answer? That are elements which are common. Okay. So here we have 1, here we have 2. So no, here we have 3. Do we have 3 here? Yes. So I will write 3. Next 5. Here also we have 5. Here also 5. So we will write 5. Then 7. So on. Okay. Is it clear, students? We'll do the Venn diagrams in the next coming video. Okay. So be connected with us.